Hello everybody, I'm Habasud and welcome to my course on uh, communication and network security. So in this class we are going to discuss about the physical security, secure connection and endpoint security. So let's start with this session. This start with physical security, having a network and cabling and conducts to protect them from accidental and intentional damage, protecting where cables come into a building and making sure that we have things like true redundancy, that we don't have two fibers in the same trench, and protecting wiring closets so people don't get access directly to switches and other pieces of network equipment. When we talk about secure wired connection, this is where we often use things like shielding can be very good to prevent some of the effect of radio frequency or electromagnetic interference or some type of induction of spray voltage onto a cable, but shield needs to be properly grounded as well. Fiber is very good because fiber does not have same vulnerabilities to electromagnetic or radio frequency interface. It is little more expensive to work with, but there are some real advantages to this. In fact, we have one of those area of cryptography known as quantum cryptography, which is looking at how do I protect communication using the photons, the light particles on fiber, so that if a person even tried to eavesdrop, uh, it would change the message and be very visible. That change that happened. Now whether or not quantum cryptography will really work in another question. There have been some challenges with it. The first few implementation were already breached, and that's nothing to do with quantum computing. Quantum cryptography is just looking at the communication over fiber and encrypting those. We also have, of course, the need of isolation. Sometimes we will make sure that a networking cable is well isolated from other power cabling, or even that sensitive cabling is quite separate from the cabling that are not containing sensitive data. We have to worry about crosstalk. Anytime I send a electric signal down a cable, we will create an electromagnetic field around the cable. This is why we twist our cables and to, of course, what we often call either unshielded or shield twist pair, so that we are able to break up that effect of electromagnetic crosstalk and interference between the various wires of a cable. When it comes to securing wireless, then we know the wireless local area networking. We used to use like WEP, also known as wired equipped privacy and Wi-Fi protected area. But now we pretty much optical. We pretty much should only be using WPA2 and WPA3 as a way to secure those wireless communication. We also have optical, where we have a light beam that goes between two different transducers. Now the problem with the optical is, while it can be very good high speed communication, it does not have susceptibility to being a line of sight and so if there is something that blocks it, it can stop that signal. But we have seen this between buildings, we have seen it in areas, because one of the advantages of optical is that it does not need the same licensing as a microwave or other radio frequency signal too. When we look at the microwave, again microwave is also for of the most of the point line of sight. The two antennas has to see each other. Even strong wind sometimes can affect the strength or quality of a signal. We also have this microwave that when the signal or the beam is coming off of the one antenna, some of it will miss the other antenna, and you can then pick up that uh, signal from even in behind that receives antenna, because there is some scatter, some dispersion of the signal that can allow it. Then it is tapped into. When we use this, we should be using encryption to protect this wireless type of communication. But in the end, it comes down to the endpoint security. You can have most secure pipe or tunnel in the world, but if the end of the tunnel are open, then it doesn't do well to have a secure network. So the whole point is we need to secure those devices that connect to our network tunnel are properly secured. We often base our approach today on what we call zero trust. We don't trust anything. Everything needs to be tested, validated, and proven to be trustworthy. It isn't just automatically accepted. We put in firewall so that we are able to filter traffic and only allow the traffic that appears to be legitimate to come through our network borders or border lines. We do not know that one of the challenges we are facing is that a VPN, that if it goes through that firewall, can present a vulnerability, because now we have an encrypted panel that goes around right through the firewall, and the firewall may not be able to do the filtering it should be able to do. But in conjunction with the things like firewall, we use anti-spam and antivirus, of course, things like intrusion detection and intrusion prevention systems. With something like antivirus, it only goods as mm, maintenance of the system, making sure use new signature files are downloading, make sure the system is turned so that it's able to be a effective control to pick up even new types of traffic, but without causing a lot of false positive alarm. The key point to review network security is a combination of having right tool that are managed in a right way by right people. So this is the end of our session, which is talking about secure network communication, no, secure network component. So in the next session, we'll be discussing about secure communication. Thank you.